Hello my dear students, welcome you back on the 6th video lecture of unit number 3, and in this video lecture we are going to discuss a next point, that is a 3.3. So 3.3, we have two video lectures on 3.3. In first video lecture we can going to discuss benefits and user and kernel thread, and next video lecture we are going to discuss multithreading models and different modules in the multithreading, many to one, one to one, and many to many. So basic learning outcomes of this 3.3 and our today's video lectures are: student must draw and explain what is meant by thread and concepts of thread in the OS. Next, student can easily explain the difference between process and thread. Then third, student can explain the benefits of threading. Fourth, student can explain different types of threads, that is user level thread and kernel level thread. And in next video lecture, our objective is a learning outcome of next video lecture of this 3.3. Second part is draw and explain different multi-threading modules. Okay, so in this video lecture we are focusing on thread, difference between thread and process, benefits of thread, and what is a user thread and kernel thread. So thread is very important concept in the operating system. So thread is a lightweight process. Okay, so very simple definition of thread is a lightweight process. So it is a process, but is it a lightweight? Lightweight means what? We can going to discuss. A thread is a flow of execution through the process code with its own program counter that keeps a track of which instruction to execute next, system register which holds a current work in the variables, and a stack which contain the execution history. Okay, so that is a thread. Previously we have studied a process, and process has a PCB, process control block, and process in the main memory also have a similar parts like a code, text area, program counter, information, state information. So thread is also a small process. It is a lightweight process which having its own program counter which gives you information which instruction is going to execute next. Also it has system register which holds the current working variables, and its own stack which contains the execution history. So it is called as a thread. Next point about the thread is a thread shares peer threads few information like code segment, data segment, open files. When one thread alters a code segment, memory item, all other threads see that. Okay, in another simple words, thread is interconnected to other threads, or it may have peer threads. They can share the code segment, data segment, and open files. All the shared information between the threads can be seen by the another thread. Okay, thread is a lightweight process. Next point, thread provides a way to improve the application performance through parallelism. So multiple threads are executed at a time. So that is called as a thread. Next point about the thread, thread represent a software approach to improve the performance of operating system by reducing the overhead. Thread is equivalent to a classic process. Okay, So threading concept is very important to improve the performance. So due to the threading concept, we have the possible multi-programming operating system. So in another simple words, a thread is a lightweight process. So single process may have multiple threads. So a single process can be divided into the lightweight processes, and that lightweight processes are called as threads. Okay, so thread is similar to process, or it is a process, but it is a lightweight. It has its own program counter, its own stack, its own segment registers. So it is called as a thread. Then next features of the threads are the threads belongs to exactly one process. Means single thread is belongs to one process, and no thread can be exit outside the process. So thread is a part of the process. Next important feature of the thread represent separate flow of control. It has successfully implemented in network servers and web server. So in the networking, we have server side thread and client side thread. Okay, so thread has its own separate flow control. Okay, so it is very important point. Next feature about the thread is thread provides suitable fundamental information, or it is a base of parallel execution. Okay, so threading is a base of parallel execution because multiple threads can be executed at a time using application or shared memory concept. So threading is used in the multiprocessing or multi-programming operating system. So threading is a base of multi-programming, multitasking operating system. So threads are individual lightweight process which have its own control of execution. So that is a basic concept of thread. So how we can draw the thread concept? So this is a diagram which explain you the threads. So it is a similar diagram how the process is in the main memory. Similarly, how the thread is in the main memory. Okay, so this is a diagram of single thread. So if a process having the single thread, then that thread has its own register which holds the temporary data as well as current executable variables, then program counter which gives you additional information of the instruction which is going to execute next, then it has a stack which holds the temporary information, then data. So data is a global information, then file information which files it is going to execute, then code section which is executable area. So it is called as a single thread. So it is a similar to your process. Okay, process requires a large amount of the memory as compared to thread. Okay, thread is a lightweight, means there is a minimum memory required for the execution. So it is a thread in the main memory. So it is a single thread. If we have a multi-threading approach, then every individual thread has its register, program counter and stack separately. So it is a thread 1, thread 2, thread 3. Okay, so in multi-threading approach we have 1, 2, 3. It may be an n thread. Every individual thread has a register, counter, stack. These are the separate. They share common data, that is a data segment, and files. So thread can share a data segment as well as a shared memory or the files which required for the execution. Also they may see or share a code segment. Okay, so that is example of, or that is a diagram of multiple threads. Okay, so this is a process having the single thread. It is a process having the 3 threads or multiple threads. So in this thread, these are the blocks which are similar to your process in the main memory. So there is no any extra explanation required about the register, counter, stack, data, file and code. Okay, so these are the two diagrams. It is a single threading and it is a multi-threading diagram. So in the MSBT question paper, there will be question explain concept of the thread. Then you must write down a definition. Thread is a lightweight process. Then list out the features of the thread. That is nothing but it has an individual program counter, individual stack and individual register. Then every process has a unique thread. Then thread has its own control. Then there are two types of thread, single threading and multi-threading. A process having a single thread can have a separate register, counter, stack, data and file, also code. Which single thread, multiple threads, in that every individual thread has register, counter and stack. They can have common data, file and code. So that is a multiple threading concept. So what is the difference between process and thread? So it is a very important question. So definition is very important. So process is nothing but it is a part of program in the execution. It is a high weight, so heavy weight program in the main memory is called as a process. A lightweight program, lightweight process in the main memory is called as a thread. Then second point, interaction of operating system. Process switching is required, or context switching, or process can be shipped using the operating system, or it is a control of operating system for the context switching. When there is a thread switching, there is no need of interaction of operating system. So it is reduces the context switching overhead. Then third, resource sharing. Multiple process environment. Each process execute the same code but on the different memory locations on different file resources. So multiple processes are executed at a time, but processor will execute a single process at a time, having the separate code, separate memory and separate file resources. But all the threads can share in threading, multi-threading approach. All the processes can share a common files, common code, common memory location also. Fourth point, process blocking. If one process is blocked, then another independent process are blocked in the multi-processing environment. While in multi-threading, one thread is blocked or waiting, second thread may have its own task because the thread has its own control. So they are not dependent. If one thread is blocked, it may run a second thread. Okay. Third, resource used in the processes. Multiprocessor or multiprocesses without having the thread use more resources. So more resources are utilized in multiprocessor environment. In multi-threading environment, they use a few resources. Okay, the need of resources are very less. Last operation, in multiprocessor environment, each process operates independently of each other. In multi-threading, one thread can read, other thread can write, another thread can change. So every thread has its own individual activity and they can run parallelly at a time. So this is a basic difference between process and threading. So what are the benefits of threading? So it is very important question. It is asked multiple times in your MSBT question paper. When this question is asked, you must write down the definition of thread first. So thread is lightweight process. It has own control, it has a register, it has a stack, it has a program counter. So multiple threads can be executed at a time. So it has two types, single threading and multi-threading. And benefits of threading are, list out the benefits first. First benefit is responsiveness. Second is resource sharing. Third is economy. And fourth is scalability. So these are the four classic benefits of threading. So what is meant by first benefit? What is meant by responsiveness? It is nothing but it may allow to continued execution of part of process is blocked, especially important for user interface. Responsiveness. Okay, so in simple words, every thread is running individually and it responds to the execution. So may allow continuous execution. Okay, so there will be definite response from the thread when it is in the running as compared to processor. So it is called as a responsiveness. So it increases the responsiveness of the operating system. Second, resource sharing. So in threading, thread can share the resources unlike a processor. So it can share a code, data, segment as well as open file. So using shared memory and message passing, the thread can easily share the information. Third advantage of threading is economy. So implementation of threading and threading concept is more cheaper than process and process relevant activity. So to manage the thread or to switch from one thread to another thread, it is very easy as compared to context switching of process. So it is economically very cheaper than process management. And last benefit of threading is scalability. A process can take advantages of multiprocessor architecture, but in threading, multiple threads can execute it at a time, so it increases the performance. Scalability is nothing but when you increase the number of inputs, it must increase the number of outputs. So multi-threading approach increases the overall performance of operating system. As the thread number increases, the outcome or output of operating system will enhance. So that is called as a scalability. So these are the 4 benefits of threading. Responsiveness very high, resource sharing very easy, economy very cheap, scalability very high. So it is directly proportional to threading. As the threading number of thread increases, the scalability of operating system increases. So these are the benefits of threading. So we have 2 types of thread in the operating system. So user level thread and kernel level thread. So my dear student, a main memory or memory space in the execution, so it is divided into 2 parts, user area and kernel area. In user area, so basically there are 2 types of threads, user level thread and kernel level thread. So user level threads are running in the user space. Okay, so there is no control of kernel on this area. And then kernel is heart of operating system. So kernel level threads are executing in the kernel space. So in this phenomena, every user level thread has its own kernel level thread. Okay, when there is a user thread is created at the user end, there will be a kernel thread created on the kernel area. Then and then that thread will be going to execute. So user threads are user managed and kernel threads are operating system managed or kernel managed. Okay, so these are the basic difference between user thread and kernel thread. So it can be easily explained using the diagram. So my dear student, so we have a process P1 and P2. So P1 has 3 threads and P2 also have 3 threads. So if a P1 is a user process and they are executing at the user space, then it is called as a user level thread. Okay, P2 also can execute in the user space, then it can be called as a user level threads. Okay, so it can be going to execute from the CPU. Okay, so logically it is multiple, but if it is a multiple process environment, it may be a physical multiple. If single process environment, logically it is multiple, because every thread executes on the CPU logically separated. It is a parallelism, means number of threads are executing at a time. Okay, it is called as a parallelism concept. So user space in which the user threads are executing, so it has a thread library, user thread library. In kernel space, it has its own threads and its own library. So basic features of user threads are: the threads are not managed by the kernel and kernel is unaware of these threads. The thread library contain, okay, so this thread library contain code for creating and destroying the threads. Also, it has information about the passing messages between a thread. It has a scheduling information. Also, it saves a temporary data as well as restores the context or shifting of threads information is stored. The applications are started with the single thread. Okay, so in user level thread, it executes in the user space. It has a thread library which contains the code, then message passing information, scheduling information, context switching information, and every application starts with the single thread. And this is a diagram for user level thread. So what is the advantages of user level thread? So user level thread advantages are: thread switching does not require kernel permissions or kernel level permission. User thread can run on any operating system. So due to that, platform independent feature or portability feature in the operating system will be available. So user level thread can be run on any operating system. Then scheduling can be application specific, okay, to the user thread. So scheduling is application specific. It depends upon individual application. Fourth benefit, user level threads are faster to create and manage. Okay, so these are the 4 benefits of user level threads. First, so there is no requirement of kernel to manage or switching. Second, user level threads can be run on any operating system. Scheduling of user level threads depend upon the application. And last, user level thread is very fast in creating and managing. Disadvantages of user level threads: in typical operating system, most system calls are blocked. Okay, in typical operating system, user threads are blocked due to the permissions. Okay. Next, multi-threaded application cannot take advantages of multiprocessing. Okay, so what is this? Because it is an application oriented scheduling, then multi-threading approach of user thread cannot have the advantage of fast execution or multi-programming execution. Okay, so these are the some advantages and disadvantages of user level thread. Then second, a kernel level thread. So kernel level threads are managed by the kernel. Then these threads, there is no thread management code and application area. So there is no any code or there is no any thread library. Okay, kernel threads supported directly by the operating system, so it can be managed by the operating system. Any application can be programmed to have a multi-threading approach. All the threads within the applications are supported within the single process, so multiple threads of the single process can be executed. The kernel maintains context switching information for process of whole or for individual thread. Okay, so kernel will manage the information of context switching. The scheduling of threads are the basic task of kernel level threads. Next feature, kernel performs thread creation, scheduling, managing in the kernel space. And last, kernel threads are generally slow to create and manage. Okay, so these threads are executed at the kernel space. So these threads are here. So in that there is no any thread library. Okay, so threads are running at the kernel space and managed by the kernel. Okay, so that is a kernel thread. So what are the advantages of kernel thread? Kernel can smoothly schedule multiple threads for the same process. or multiple processes. So smooth conduction of thread scheduling by the kernel. Then second advantage, if one thread in process is blocked, then kernel can schedule another thread of same process. Okay, so that is the duty of kernel, and it can be easily executes another thread. Third, kernel routine themselves can multi-threaded. Okay, so kernel supports multi-threading approach, while in user level thread, multi-threading has a dependent upon the application. Disadvantages: kernel threads are generally slow to create and to manage. Second disadvantage, transfer of control from one thread to another thread with the same process requires a mode of switching of kernel. So there is a similar methodology as the of context switching is used. So it is very slow as well as a very tedious task to shift the thread from one thread to another thread. It requires to change the mode of kernel. So reflection point of this session is, what is the benefits of the thread? My dear student, stop this video, write down your answer. After that you can play this video again. So there are 4 benefits of kernel. Responsiveness, so operating system responsiveness of individual thread will be increased. Resource sharing in multi-threading or single threading is very easy using message passing and shared memory concept. And third advantage, economical, it is very cheaper to have a threading approach. Then scalability, it increases the performance as the thread increases. So these are the benefits of thread. So up till now we have seen what is meant by thread, then basic features of the thread, then types of thread and benefits of the thread. So my dear student, thread is lightweight process. It is similar to process. Its diagram is similar to process in the main memory. So it has its own PC, program counter, stack and register. So we have a single thread, multiple thread approach. Okay, then we have 2 types of threads: user level thread which runs in the user area and kernel level thread which runs in the kernel area. And then we have 4 benefits of threading: responsiveness, then resource sharing, economy and scalability. So these are the 4 benefits of thread. So we can stop today, and in next video lecture of 3.3 we can discuss what is the multi-threading and multi-threading modules, in which we are going to discuss one-to-one, one-to-many. So one-to-many is not there, many-to-one, one-to-one, many-to-many approach of multi-threading. Till then, stay at home, stay safe, stay healthy, happy learning.